So along those lines, Azure SDKs come with some standard retry policies, and if you do absolutely nothing, you just use the SDK out of the box, and you write code that reads or writes blobs, it behind the scenes is already by default configured to retry up to 3 times, and with a what's called an exponential backoff. So the simplest retry is to just retry right away and just keep doing that. A little more sophisticated retry is to recognize that, well, there's probably a reason I'm retrying, because the service is a little bit hot at the moment. And so this is a linear backoff. So you might wait half of a second before you retry, and then wait another half of a second if you have to retry again, that kind of thing. Then there's also an even more forgiving one, which is known as exponential backoff, which retries after, say, a quarter of a second. Then if that doesn't work, it'll retry again after another half a second, and then again after that after a full second, and so forth. You can see that the retry interval is doubling each time. And furthermore, you can have custom retry policies. For me, I haven't really found that a custom retry policy is needed, because I thought of a new retry approach, like random retry or something. That actually might be a decent one, frankly. But that's not why I did it. But I did write a custom retry policy for a project because I was uploading a ton of data and I wanted logging. I wanted to know how often I was actually doing a retry. And the link to this is in there. But basically, I create a custom retry policy, and it's just like the exponential backoff that comes with the SDK. So it just mimics that. There's nothing different in that regard, except that it allows me to do some logging, and I can calculate some statistics and so forth. So you can look at this if you wish, but just the useful thing for me again was that it logged it, and I knew that in my giant log file, I had a process that ran for more than a week, uploading terabytes worth of data, and it would tell me that it would go for great stretches without any retries. Then there would be an occasional retry, and sometimes there were a lot of retries. So that allowed me to keep tabs on things. So that's custom retry policies. And another sort of retry that I've encountered occasionally is it has to do with containers. So I mentioned that within your storage account, you can have blobs, but the blobs always live in a container, just like in a file system, a file always lives in a directory or a folder. And Azure has a consistency model, which is known as strongly consistent. Fully consistent, there's a few various names for it, but it's the opposite of eventually consistent. An eventually consistent model is one where you might save data, and then if you read the data back right away, you might get the old data. And typically an eventually consistent model spans a very short amount of time, like a fraction of a second. So it's not like your data is going to be stale for hours. But Azure, for the storage subsystem, they've chosen to use a strongly consistent model so that you are guaranteed that after you write it successfully and read it back, that it will be the same thing that you wrote. There's one little funny bug or behavior, I don't think it's a bug, I think it's sort of documented, is that if you delete, so this has the strongly consistent part applies very nicely and consistently with blobs. But if you ever delete a container and then recreate a container with the same name, that container name is not available for a short amount of time. There's some sort of a garbage collection going on. So if that ever, if you ever need to overcome that, I've used on a couple of projects as well, is patiently create a blob container where this takes that into account and handles the right exceptions to determine that that this is not another kind of failure. This is actually the kind of failure that happens when Azure is trying to recreate a blob container name, and the old one hasn't fully gone away. So again, using the storage client SDK in C# code here, and create if not exist. Some of these have changed subtly. There's an S there now in the new SDK, and this is client. This is not storage client exception, just storage exception. They've cleaned up a few things, took the opportunity to do that in the 1.8 one that I mentioned. But anyhow, that does what I just said. It will keep going until, for half a second or a few seconds until it's able to fully curate the new container name. So those are some new some thoughts about programming the blob service. Now let's talk about blobs having reach. So the blob service itself is available in 8 data centers. And these are the 8 Azure data centers. There are 4 of them in the US, 2 in Europe, 2 in Asia. So let's take a peek at that. So if we go to the management portal, let's go to manage.windows-azure.com. And what I want to look at is creating a new Azure Blob account, and I want to point out the options that are available there. So if we go to the storage service here, those are existing ones. I'm going to create a new one, and it's data service, storage, quick create, and again, I choose data center. So this is the point I wanted to make. There are these 8 data centers: West Europe, Southeast Asia, East Asia, so 2 Asia, 2 Asia, 2 Europe, that's West Europe and North Europe. The West Europe and North Europe ones are in Dublin and Amsterdam. The Asia one's in Singapore. I think the other might be in Hong Kong. And then the South Central and North Central U.S. are in Chicago and San Antonio. And then East and West are in Virginia and might be Washington or something for the West one. And another dimension of this is these are actually paired. This becomes important in a minute. So East and West are paired in the U.S. South Central U.S. and North Central U.S. are paired. North Europe and West Europe are paired, and Southeast Asia and East Asia are paired. And each of these pairs are geographically separated, and they're in the same geopolitical region. So sometimes there are data issues that have to do with your data moving out of, say, the EU or out of the US with certain regulatory compliance issues. So that's an important thing to understand. We'll talk about that again in the context of, in the next bullet point, the next number 6, in the context of making copies. Now, Azure also has a content delivery network built into the platform. So you can CDN enable a blob, your blob storage. And the CDN, for those who aren't aware of it, is a content delivery network. That's the full name. And the content delivery network consists of 24 nodes around the world, or points of presence. And these include the 8 data centers, and there are 16 additional ones that are geographically distributed, Australia and South America and a number of other places. And these are cache nodes, essentially, that will store a copy of the data that was requested from your blob in a local storage system, a CDN cache, a point of presence in, say, Chile, say, and anybody else who is close to that point of presence who requests that same data we'll be able to get it from the much closer CDN point of presence, improving performance. It uses Anycast DNS, which is a standard DNS thing that says, hey, what's the closest DNS server or what's the first DNS server that answers my DNS request, my DNS lookup? And that's how it knows which of the 24 POPs is closest. I'm doing air quotes here with closest because it's not necessarily the geographically closest. It might be a further away one that just has a better internet connection or less congested internet connectivity to that point. And this is pretty powerful. You just turn on the CDN. However, the CDN only applies to public blobs. We haven't really talked about that yet. We'll get into it in the valet key pattern. But a blob is either protected or it's public. And the CDN only applies to blobs that are public. And furthermore, the headers, the HTTP stuff that we talked about earlier, setting cache headers and so forth, that still applies here. So any HTTP headers like a cache expiration or MIME type and so forth, these carry into the CDN, and the caching one in particular governs how long it would be cached in the CDN. So pretty powerful that you can, with a couple of clicks of the mouse, say, I want to just enable CDN access. So that helps you with global scale.